Hi, and welcome to our next video. This video will cover section 3.2 and talk about domain and range. If you haven't already, please go and print out or download into your tablet, or at least look at the blank notes that I'll be going over in this video. It is very important for you to take written notes. So if you can't print them out, that's fine, but do take notes in your notebook as you watch the video. All right, by the end of this section, you should be able to use interval and set builder notation, find the domain of a function defined by an equation, and graph piecewise defined functions. All right, remember from our last video, we talked about the domain of a function, and remember it is the set of all possible inputs. Input variables are also called independent variables. They are found on the horizontal or x-axis. So remember, it's x in the input, in the independent variable, and that's on your horizontal axis. The range is your set of all outputs. So let's squeeze this in here. Y is your output, which is your dependent variable, which is going to be on your vertical axis. All right, so the domain leads to your function spits out your range. Lots of times we write D equals or R equals to list the domain and range. If we look at this figure, the domain in this set is the set A, B, and C, and the range is the set X, Y, and Z. Let's do an example. Here is a function defined as a set of ordered pairs. Remember, when you define a function as a set of ordered pairs, the input is the first variable and the output is the second variable in the ordered pair. So in this example, let's look at my domain. Remember, my domain is going to be my input. So there's 1, 2, 3, 5, and 0. And sets are able to be listed in any order, so you can list those in any order you want. 1, 2, 3, 5, 0. My range is all my outputs. So here's my range: 3, 4, 4 again, 7, and 0. 3, 4. I only need to list 4 once, because if it's in the set, it's in the set. So you don't need to list it again. 7 and 0. All right, let's talk about interval notation. Before we jump right into using interval notation, let's back up a little bit and remember how we used to write inequalities. Let's think about the inequality that would represent this sentence. Suppose we had a function with a domain of all numbers greater than or equal to 5. How would we represent this as an inequality? We want x to be greater than or equal to 5. Let's graph this inequality on our number line. So since it's greater than or equal to, we're going to put a closed circle at 5, and we want any number that falls into that category is going to be any number 5 or bigger. All right, let's do another example before we jump right into interval notation. Let's say we had a function with a domain of all numbers less than -2. Let's write the inequality. X is less than -2. Take a moment, pause the video, and try and graph this on a number line. All right, hopefully you graph this on the number line. Since this is not inclusive, it's just less than, not less than or equal to, we're going to draw an open circle at -2, and we're going to include any numbers less than -2. So all these guys down here. I didn't do a great job of coloring there, but there you go. All those guys. Now we're going to write the interval notation. The interval is the smallest number that is included, comma, the largest value that is included. If we look at x less than -2, the smallest number is way down here at -infinity. And the largest possible number is anything as close as you can get to -2, but not included. So we're going to go from -infinity to -2. And we're going to use round parentheses to not include the endpoints. So this is for if you have less than or greater than. If you want to include the endpoints in interval notation, you use square brackets. So square brackets for less than or equal to or greater than or equal to. Now that we know that, let's go back up to our first example and see if we can write the interval notation for this one. Well, if we look at this, the smallest possible number is 5, and the largest possible number is positive infinity. So we're going to start at 5 and go all the way up to positive infinity. And I'm going to put a round parenthesis on infinity. That's sort of a style thing. So it isn't wrong to put a square bracket on infinity, but since you can't ever really get to infinity, most people use a round parenthesis always when they're putting down infinity or negative infinity. All right, let's go over a few things about interval notation. Remember, you always write the smallest number, comma, the largest number. You use parentheses if you do not want to include the endpoint, and you use brackets if you do want to include the endpoint. There's one more way we're going to write domains, and that is using set builder notation. So let's go ahead and practice with this example. We want to represent a domain of all numbers between 5 and 10 on a number line. And since it doesn't say including the endpoints, we're going to assume we are not including the endpoints. So for an inequality, we're going to have 5 is less than x is less than 10. All numbers between 5 and 10. Let's graph it on a number line. Here's 5, open circle, because it's not inclusive. 10, open circle. And we're going to include everything in between it. Writing this in interval notation, our smallest number is 5, not including the endpoint. Our biggest number is 10, not including the endpoint, and we add a parenthesis. All right, so set builder notation. Set builder notation really goes back to writing the inequality. So to use set builder notation, you write first a curly bracket. That means the set of all. The set of all. And you want the set of all x such that, and I'm using some math shorthand here. This vertical bar means such that. We want the set of all x such that, and now we just stick this inequality into our set. 5 is less than x is less than 10. So that's how you use set builder notation. These parts of set builder notation that I'm going to highlight in blue are always going to be the same. The set of all x such that, and then you end the parentheses. The part in here is where you put your inequality that describes your domain. So let's go back. I've been doing that a little bit in this video. Let's go back and put this last example in set builder notation. So this, if we look at the inequality, is, well, the set of all x such that, and now we just plug our inequality in. X is less than -2. Close your brackets. So that's set builder notation. Very often, textbooks will require either set builder notation or interval notation. It just really depends on what people's preferences are. And here's a table that you can refer to if you're having a little trouble remembering how all the inequalities work. Pause the video and take a look at it, or you can, of course, print this out from the notes. I think that's the end of the first video. Yep, that's the end of the first video. So go ahead and watch the second video if you're ready.